So again, picking back up, I try to put my 3 between the 2 and the 4. Therefore, it matches on my number lines. So we want to know what's the acceleration between 0 and 3. So if you plug in something like a of 1, you're going to get a positive. If you plug in a of 5, you get a negative 30 plus 18, so you get a negative. So it's positive over here, negative over there. So again, that means accelerating in that direction. It doesn't mean speeding up or slowing down. Motion or speeding up and slowing down come from matching signs or opposing signs of velocity and acceleration. So we have to take into account actually both of those. So we're going to make a third set of lines where we compare the change in signs at all. So you're going to look at 2, 3, and 4. So from 0 to 2, velocity is negative, acceleration is positive. So since their signs are opposites, it's slowing down. From 2 to 3, positive, positive, speeding up. Three to 4, positive, negative, slowing down. 4 and beyond, negative, negative, speeding up. So again, speeding up and slowing down have to do with both velocity and acceleration as well as their signs. The position is the point at which the particle is at that point. So position is kind of like saying not displacement, but position at that particular point. So the first thing we need to do is figure out what is my starting position. So what is S of 0? So in this case, S of 0 is 1. So the starting position is 1. And then we know that the particle is going to the left for 2 seconds. So that tells me I need to know the position at 2 seconds. Which it's negative 19. From 2 to 4, it's moving to the right, so I've changed direction. So it's like left, right, left again. So at 4, it's at negative 15. And then after 4, it's moving to the left infinitely. So what I'm going to do is start at 0, 1. So in terms of position, here's 1. This represents t equals 0. Then my particle goes all the way to negative 19. And that's at t equals 2. Then it goes backwards to 15 at t equals 4. And then it changes direction again and it stays in that direction infinitely. So it goes left, changes direction, goes right, changes direction, stays left. Let's look at a word problem. So it says a .45 caliber bullet fired straight up from the surface of the moon would reach a height of blank feet per second on Earth in the absence of air. Its height would be, etc. How long would it take the bullet to hit the ground in either case? So we know the object's going to go up, and then it's going to come back down. So this represents position. We need to know when position is 0. Oh. And then simply just solve the quadratic. So you can take out a 16, let's take out a negative, let's take out a t. So it should always have an initial at 0 because its starting height is on the ground. And then the other time is 52 seconds. This one would be trickier.